Module A1, Objectives 3 and 4. Objective 3 is to understand how atomic properties influence reactivity and bonding. Objective 4 is to differentiate between covalent, ionic, and hydrogen bonds. Ionic bonds form between atoms or molecules that carry electric charge. Cations, positively charged ions, and anions, the negatively charged ions. We talked about this in the last objective. You may recognize this slide of a sodium chloride crystal being held together by ionic bonds. The positively charged sodium ion is surrounded by negatively charged chloride ions, and the negatively charged chloride ions are surrounded by positively charged sodium ions. This produces a regular crystalline type structure, and if you have ever used salt, then you have seen this structure come out of your salt shaker. Another thing about ionic compounds is that ionic compounds have a tendency to dissociate in water. So if you put a sodium chloride crystal into a glass of water, it will seem to disappear. And that's because the sodium ions and the chloride ions are separating within the water. And we'll explain more about why that happens. A second type of bond is a covalent bond. Covalent bonds are by far the strongest bond that we will be experiencing in anatomy and physiology. Covalent bonds are strong bonds formed when atoms complete their outer electron shells by sharing electrons. If you remember from the previous PowerPoint, the octet rule, where electrons in the outer shell usually equal 8. There are some differences in that we're not going to get into. You'll learn more about that when you take chemistry. But for our purposes, the outer shell should have 8 electrons in it. Unless you have hydrogen, which only has 1 electron in its outer shell, and its outer shell happens to be the first valence shell, and that is full when it has 2 electrons. On this page, you can see the oxygen molecule that has 2 pairs of shared electrons. The atomic number for oxygen is 8. Which has nothing to do with the octet rule. But you can see it has 2 electrons in its inner shell, and 1, 2, 3, 4, 5, 6 in its outer shell. It's missing 2. So it satisfies that outer shell by sharing electrons with another oxygen atom. This produces that diatomic molecule that we've talked about before. So you see an oxygen double bonded to another oxygen. This line represents a covalent bond. Since there are 2 lines, we have what is called a double covalent bond. If there were a single line, it would be a single covalent bond. Covalent bonds come in 2 types: nonpolar covalent bonds and polar covalent bonds. Nonpolar covalent bonds involve equal sharing of electrons, usually because the atoms involved in the bond have an equal affinity for electrons. The term for the affinity of an atom for its electrons is called electronegativity. Electronegativity is the measure of an element's affinity for electrons, and that term affinity means attraction for. If you are affectionate for someone, you are attracted to them. Oxygen and nitrogen. Oxygen and nitrogen. Oxygen is O, nitrogen is N. That's the chemical symbol for those. Have a great affinity for electrons. They're highly electronegative. hydrogen and carbon, H and C, have a lower affinity for electrons. What would you expect to happen when oxygen shares with hydrogen? If oxygen has a greater affinity for electrons, it's more electronegative, the electrons will spend more time with oxygen and less time with hydrogen. So this picture is from your text, figure 2.5, and it shows the formation of a water molecule. Hydrogens come in and share their electrons with oxygen. They don't share with each other, just with oxygen. And they form this water molecule. But the water molecule is unique in that it is a polar molecule. The electrons have a tendency to spend more time around the oxygen than they do around the hydrogen. Because of this, the oxygen end of the molecule will have a tendency to be a little bit negative, and the hydrogen ends a little more positive. And that's what these symbols mean. This means positive charges on the hydrogen ends and 2 negative charges on the oxygen end. This makes the water molecule a polar molecule because of what is called a polar covalent bond. The electrons are unequally shared because the oxygen has a greater affinity for the electrons. This allows for our third type of bond, the hydrogen bond. Hydrogen bonds are weak bonds. They are more like attractions formed between electrically charged regions of an otherwise neutral molecule. If you think back to that water molecule, you have the oxygen and the 2 hydrogens. Overall, there was no charge. We had negatives on the oxygen end, positives on the hydrogen end, but the 2 positives and 2 negatives canceled each other out. The overall molecule is neutral. But because of these attractive forces, because one end is a little more negative, it sets up the ability to form hydrogen bonds. Again, hydrogen bonds are bonds between adjacent molecules, not atoms. They involve slightly positive and slightly negative portions of polar molecules being attracted to one another. And hydrogen bonds between water molecules cause what we call surface tension. If you've ever seen an insect walking on the water, that's because the weight of the insect is not strong enough to break the hydrogen bonds between the water molecules. This is figure 2-6 from your textbook, which shows the idea of hydrogen bonds, where you have the positive end of the hydrogen portion and the negatively charged region of the oxygen forming that. And what they're showing here is a dashed line. Oftentimes in the pictures you'll just see 3 dots, and those 3 dots represent a hydrogen bond between those regions. This becomes very important later on when we start to talk about some other molecules like DNA. The DNA molecule is held together by hydrogen bonds, one portion of it. Hydrogen bonds are what allow for our bodies to form solutions. The solubility of substances within water have to do with these hydrogen bonds being formed between the water molecules and those substances that are being dissolved. We will talk more about these 2 concepts later on.